Hello and welcome back to a bonus episode of the Oxford MAT Livestream. My name's James and today we're looking at Oxford interview information for maths and or computer science. Good to see you here. Welcome back after the MAT again. This is a bit of a different one because not only are we not getting ready for the MAT, we're not even talking about the MAT, we're talking about some other maths that might happen at a maths interview. If shortlisted for interviews for maths or computer science at Oxford. Hello people in chat, hello. It is actually the last one this time. So hi James, I'm at the gym right now. Hello everyone at the gym. There you go. Brilliant, the gym's got a shout out. What a world we're living in. Yep, last one, there we go. We've done quite a few this year, but this is a finite sequence, which is going to be this one, and it's sort of included in the MAT Livestream thing partly for clicks because I know you know what that is, but also partly because we're looking at similar skills really. Now, two things I want to do at the start. Firstly, we wanted to thank Callie, who's moderating chat again, right? Is it Callie again today? Have I got that right? It is Callie. Hello, thank you, Callie. Callie has done a bunch of these, not just this year but over several years. So let's put thanks Callie on the screen. I don't know if they're watching, but they're definitely in chat. There you go. You could say thanks in chat if you like, and we've had various students moderating things along there as well. I would like to do the normal stuff we do at the start of the stream, which is to ask you how your day's been, and I want to do some obvious things that I know are going to be frequently asked questions in chat, so I'm going to try and do them at the front, which are, at the time of recording, no interview invites have gone out yet, no deselections have gone out yet for maths or computer science at Oxford. I'm expecting those to go out starting next week. I'm not expecting absolutely all of them to go out next week, but looking at my calendar, it is currently the 27th of November. I am expecting emails to start being sent by the various colleges of Oxford week starting 1st of December. And I'm hoping to get most of them out 5th of December because interviews are not long after that. Maybe I should say, maybe I am expecting most of them, really most of them, to be done by Friday the 5th of December and out there. And I've got some what, where, when, why, who and how questions to deal with. So we'll do more information. My plan for this is to spend maybe 20 minutes, half an hour doing the kind of questions about what interviews are like. And then I have a question that I used last year in maths interviews, and I'd like to walk through it with you. We could try doing the question, and maybe we could talk about what I'm trying to get out of that. So the when question from anonymous and a different anonymous person. Sorry, I'm gonna. Let's put it on here as well. Let's zoom in. So like invite emails. And this is going to be about 1 to 5 of December-ish, approximately, and then actual interviews are mostly in the week that starts 15th of December. Well, let's go mostly end of. Oh, hang on. How am I going to phrase this? Sorry, I've sort of changed my mind halfway through that sentence. So mostly it's week commencing 15th of December or the second half of the previous week. So there's some happening in that week of December for maths and computer science, maybe even the first half of that. This is still mostly. So the week, in Oxford terms, it's 9th week of term. That doesn't mean anything. So 8th to 12th of December, and just in case anyone's watching the recording, it is 2025 at time of recording. Mostly that week commencing 15th, as that's Monday, Tuesday, Wednesday, and possibly Thursday, but hopefully not too much on Thursday. Quick update: chat is having a terrible day, and I'm not ignoring that. What is that? 19% on 1 star? That's terrible. That's like the highest proportion of bad days we've ever had. I wonder if that's like related to the thing that's on the screen right now. Yeah, okay, good. I think we've hit when. let's clear that. Callie's been thanked. Callie in chat says thanks. People in chat are hoping that I do my triangle question again, because I do my triangle question quite a lot. Sorry, I'm doing this a lot as well at the moment. I'm not planning to do the triangle question this time because I've already done it at open days, but now what's happened is that you've mentioned it in chat, which means that the however many people who don't know what my triangle question is will want to see it, which now means that we're doing it. So I'll tag that on the end. Let's make a little set list for myself here. Do the triangle question. Okay, and I also have the 2 + 3 is 5 question. Right, that's my set list. Eric says we all know the question, which I think is exactly the sort of thing where I did an open day, I've done it in a previous video. Nope, shouldn't assume people have seen things. Let's do our who, what, where, when, why. I hope people have. So I saw that people have voted 1 star there. That's pretty sad. Normally I would say, I hope thinking about some maths cheers you up. That's still 20 minutes away, I think. So maybe go make a cup of tea or something, and then come back and we'll do a maths question together, because I want to do the information side of this first. Let's work our way through these questions in some order. So where the interviews for Oxford are online. We've been doing online interviews for everyone since the pandemic, but we've actually been doing online interviews for overseas candidates for about 20 years. So we've done a lot of online interviews. We've worked out, I think we've worked out a pretty good way of doing those. We found that we can still do all of the stuff that we want to do in an interview online, asking people questions over a Teams call. So we have something like Teams to do the call, and where possible we use an online whiteboard like this one if people can access it. If that's not possible, we've got other plans as well, but where possible people join this in a separate tab or a separate device or on a phone or something so that they can see. Failing that, I've done things like screen share so that I can at least show people what I'm doing, and failing everything, there is always write something on a bit of paper and hold it up to the camera. I was considering switching to just full screen camera there, but it's a bit of a jump scare, I think, if I'm suddenly the whole screen. And there's a question about content in chat. Do I prefer, so the setup, the person who's asking about visualizers or an iPad or whatever, to be honest, we can work with whatever. I'm not expecting visualizer. I think visualizer is quite rare, and I wouldn't start an interview by saying get out your visualizers, because there was a thing during the pandemic where people were balancing phones on top of stacks of books and things, and I thought it was quite precarious. So I've been using these online whiteboards where I can. Ruben, if you can't afford paper, we will maybe send you some paper. Right, okay. The dates are, so the whens of it are invites, just to clarify for Aaron in chat, I think. We tell you when the interviews are. If you can't make it, then please reply to the email. Please don't turn up. What's the way to phrase that? Please don't not turn. Please don't just not turn up. Please reply and we'll try and rearrange if we can. Right, okay. So online calls. I should do the why really quickly, and maybe this is a little bit of the who as well. For maths, we're interviewing about 3 people per place, which means about almost 600 people invited to interview. That's not the same number of people as we have applicants. We're doing the interviews because we want to see people doing maths. That includes computer science. So computer scientists, I know less about computer science than I know about maths. I have sometimes interviewed computer scientists and just asked maths questions in my role as a maths tutor. At New College, we sometimes like to give the computer scientists a maths interview just for that comparison. Just for more maths fun. we want to see what happens when you get stuck. I'm going to put this as a question here. Now, we have some data on this from things like the math submissions test, where we've done tricky questions. We've set tricky questions and we've seen what happens when you're stuck on these tricky questions. But interviews are different because in an interview, we can give prompts. The interview is usually 2 interviewers who might take it in turns to talk, or who might both talk, or it might be the case that you have one person talking and one person taking notes. That's how I do my interviews at the moment. I have me doing all the talking and I have somebody else in the call just to take notes on what's going on and track who said what. So usually 2 interviewers who might be tutors at the college. They're almost always involved if they're teaching people on the course. They're almost always involved in admissions, but also might be DPhil students who have done training. There's a range of different teams interviewing. If you're interviewed at Oxford for maths, you'll almost certainly have 2 interviews with different colleges. So let's put that in that's sort of a how thing, I think, or maybe it's a what. So what is this? So it's at least 2, let's put usually there. Occasionally someone is in a very distant time zone and we just cannot find a way to find a seconds time that people can do. So usually 2, 20 to 30 minute, and this is usually as well guidelines, not a strict rule, calls about maths. I'm putting calls because these are online calls. Let's put online in here. Online calls about maths, where you should expect to solve problems. I'm being vague about what those problems are. It's not the case that we've got a set syllabus for this. For the MAT, we can't help you with the questions while you're doing them. We're not there. So for the maths, we have a really specific syllabus. You've seen it, I'm sure, this 1 page of A4 that lists maths topics. Whereas for interview, we can go a little bit wider. We can bring in new things entirely and maybe teach you something on the spot. We can bring in other topics from maths or further maths or equivalent, provided that we've made a plan for what we will do when we meet people who haven't yet seen that in school. The interview is happening before the end of school, so we know that we can't expect everyone to have seen every topic that they're going to learn before the end of school. That doesn't always stop me, because I know that if somebody hasn't met it before, I can get some good information about what happens when they're learning something new on the spot. What happens, it's not the same experience, but it's a useful experience for me, at least, doing interviews. How many students are interviewed? Oh, so Eric wants numbers for computer science. I think it's about 3 per place. Something like that, yeah. Maybe a little bit lower, but I think it's about 3 per place. So in raw numbers, gosh, I can't remember off the top of my head, but at most a couple of hundred, I think. Was it 60 for CS at the moment, or is that 60 for maths and computer science? I should know these numbers. Some, not most of the applications, I'm afraid. Shortlisting down. Okay, so we're applying 1 year late and you've finished year 13. We could get asked year 2 content. Yeah, of course, why not, right? And also, if you haven't finished year 13, you could get asked year 2 content because you're in year 2. I mean, this question is interesting to me, right? Because I don't know if this person is like, this person has finished year 13 and they seem slightly nervous about the idea that they know mathematics, but like, don't be nervous. You know mathematics. You finished year 13. You got the grades, right? Probably. Like, surely I should be allowed to ask you about stuff you definitely know. James is having a 4-star day. Thank you for asking. I'm now looking at chat. Can you tell? yeah, if you say you've never learned something, when you had, and then shocked them by being insanely good, in general, I think I'm quite good at detecting. Well, so firstly, I don't think people actually try this. And secondly, I think you're going for a maths degree, not an acting degree. So presumably you're better at maths than you are at acting. I don't know, maybe you're amazing at both. My caution to people considering this is that you're probably not as good at acting as you think. Right. Is it equal number of people invited from both MAT days? Maybe. That's not something I've counted. What content is expected knowledge? Yeah, so expected knowledge is an interesting question, right? Because we're not really trying to test what you've learnt in school. Let's maybe put that on the board somehow. So people are quite nervous in chat at the moment about, I think, maths topics that might come up. We're not really here to ask A-level questions at interview in the same way that you get A-level questions on topics. Because, well, if you imagine being in my shoes, right? If I spend a day interviewing people and I ask them A-level questions, what I'll learn is mostly whether people have met those topics or not. If I ask about tricky A-level topics from the end of A-level, then mostly I'll learn whether people have seen that topic yet or not. And that's not really interesting to me because by the time they come to Oxford, they will all have seen all of it. So in some sense, I'm measuring something that is not relevant. So instead, when I'm designing interview questions, my preference is to go a bit more basic. And my preference is to do things where I know that everyone has seen it. Some of my colleagues go the other way. Some of my colleagues like to ask things that they know that nobody has seen. So some of my colleagues like to level the playing field by making sure things are challenging for absolutely everybody. That's a different sort of challenge, right? So I tend to go towards triangles and parabolas and things, which some people have seen. One of my example interview questions, triangles and parabolas, right? And the other way that people sometimes go is to go really hard. The third option is, of course, to do something where you can adapt it based on students, to do a question where, depending on what they've seen, you can ask different things. That's a bit harder to do. Right. Can I expect much to be asked about the personal statement? Not usually, I would say. I want to do some maths. I can read your personal statement whenever I like, but while I've got you in the interview, that's my chance to actually do some maths with you. Is this true? Have I never asked someone about their personal statement? I think a few times I've asked people about their personal statement. I find that not very interesting generally, so I don't do it very much personally. And was that a threat? What did I do? Oh no. Did I back up? What did I do? I was threatening. Yes, there was a bit where I stared down the barrel of the camera and said that things challenging for everybody, which was maybe a bit too. I'll try and tone it down a little bit. Will you ask why we want to study maths? No, I think that would be a boring question because we already asked you that on the personal statement. Why Oxford is silly. We know that we're the best. We cannot ask why the college choice because we don't know that you chose the college. You might have made an open application and been allocated to our college. We don't know. So we can't ask you why you chose the college because you might not have. We can ask you about your personal statement. Personally, I would rather get on with some maths. What have I not done yet? I haven't done... Have I done who? Well, so I've done who of you and I've done a couple of us. I haven't really talked about the Oxford way of doing multiple interviews. It's on the board somewhere, but this idea that we know that people tend to be a bit nervous in their first interview. That tends to make me a little bit nervous as well when I know that it's somebody's first interview and I have to set a good impression for what interviews are like. But in Oxford, we interview people at least twice, almost always. If you're in a very distant time zone, we're going to try, just so that I can say always. And because we want to see you. Because we're interviewing multiple times, we get a range of tutor opinions and we get a range of experiences. We get to ask people multiple things. And I think that's good because occasionally people come out their first interview and they might not have got very much done, they might have been quite scared, but now they know what to expect or now they know how it works. Of course, I'm trying to prime you for what to expect, which is people are there and they ask you maths questions. Right. How important is knowing everything on your personal statement? Well, it's your personal statement, so presumably you wrote it, so you should know what's on it because you wrote it. You shouldn't be surprised if something on your personal statement comes up. Some of my colleagues I know try to use the personal statement as a way to make somebody feel comfortable at the start of an interview by saying, aha, on your personal statement you've read this book, I also read that book. What did you think about the book? And maybe that will make you comfortable, or maybe not. With different interviewers, something I'm trying to, I suppose, get across today is that I'm one interviewer. There are maybe about 100 people doing interviews with maths and computer science, and we have a lot of academic freedom to do different things. We have obviously guidelines for what we're looking for. We're all looking for best candidates for the courses, but our behaviour in interviews and the ways that we might try and surprise candidates by showing them something new, mathematical, or asking them a question they haven't seen before. There's a lot of freedom there, and I'm not trying to box in my colleagues. Does Oxford consider teacher reference for the interview? Yes, very much. We've already looked at teacher references, of course, because we've got those. Often they've got really important information in, and often they tell us how great you all are at maths or computer science. Oh yes, let's put what? Thank you, maths and philosophy student, waiting there very patiently. Maths and philosophy students should probably expect, I'm going to say should expect separate philosophy interview. Have I mentioned second colleges? So this is an Oxford thing, that if you're interviewed at Oxford, then almost always you're interviewed by a second college, which might mean that you get one or more than one interview with a second college. That's done for everyone, or almost. It doesn't mean anything about your application. We just like to get people seen by a second team of people, so that although we're at different colleges and we're each trying to get the best students, if one of our colleges has too many good students, then at least they've been seen by second colleges who can then, like, you know, hungry hippos, right, can just like, you know, gobble up, grab some extra points. So maths and philosophy students might end up with 4 interviews. It's not unheard of for it to be more than 4. I think at New College we do. I'm at New College, where I think we do a standard 3 interviews for first college candidates, and then I'm not sure we do 3 for our second college candidates, but we do a couple for maths and philosophy. I think there's quite a lot of interviews in the end, but we think this is a good thing. We think this is lots of opportunities for people to demonstrate that they're the right candidate for the course, and lots of opportunities for, rather than think about it like that, perhaps lots of opportunities to just do some maths with us, or philosophy with us, or just have those conversations and get some experience. I think my best interview questions are the ones that actually show you a technique or something useful, so that even if you don't end up coming to Oxford, and even if you didn't really like the overall experience, at least you've learned a thing now. I think the best math questions are like that. I know everyone's still grumpy about maths, and this is not the right time, but I think the best math questions actually make you better at maths. Right. I feel like I'm not allowed time to think during interviews. So we're not mind readers, and if you don't say anything, we will try and work out what you're thinking by asking you. I try not to give people hints unless I think they need them. And often, I think my best interview strategy is to shut up and listen, because I want to see what the candidate's doing. So I know what you mean about trying to time to think. It's slightly artificial, but I do encourage you to think out loud. Maybe we'll do this. Where am I going to do this? Top tips? Let's do a top tips column. Top tips. Top interview tips with James from Oxford. Hello. Top tip number 1 is listen to the interviewer. We are telling you what the question is. We can help you, and if the question is too hard, which is one of the things that I might try to do, is to make the question too hard, then I might substitute the question with a kind of sub-problem, or a way to break down the problem. I might suggest a way to attack the question in a different way, or something like, what if all of these spiders were there was just one spider, right? I don't know, whatever. What is that question? My goodness. But what if there was less going on? Which might give you a smaller thing to think about. Everyone's thinking about spiders now. What have I done? Melons, watermelons. No, terrible. What is my question concept? It's always like, oh, Derek has 37 watermelons. Now that's like a classic maths question. Let's go for that one. Derek's got 37 watermelons. You're like, well, there's too many watermelons. I can't think about all of those watermelons. So the interviewer might say, well, what if it's just one? And then hopefully your intuition of imagining one watermelon might give you a way to imagine lots, or a way to get back to the main problem. I have gone off on a tangent here, haven't I? This has gone weird. So listen, because we might be adapting the question, we might be helping you, we might be clarifying something. We don't even make shorts of these. Maybe we should make shorts of these. If you apply at New College, gosh, if you're at New College, if you're shortlisted at New College, I think I'm interviewing all of the maths candidates at New College. You may not use this chat threads to try and influence that experience. I won't remember who you are, and as I say, I'm interviewing all of the maths candidates who are shortlisted by New College. So there we go. Right, listen. What's this one going to be? Say what you're thinking. This is a bit artificial. I know that normally when you're working on a maths problem, you don't talk out loud while you're doing that, probably. I mean, maybe you do. But there is something about if you just start quietly integrating, then it's a little bit harder for the interviewer to tell what's going on and to help. But if you say, I'm going to integrate this with respect to X, then the interviewer can think, hooray, great, and can maybe even say, yeah, carry on, let's see what happens. Which is not a hint, it's just you announcing what you might do next. So there's a suggestion in the chat that, look, what if you start getting a hint and you realise you want to stop them, but they say too much? Like, I mean, you can say as soon as you said one watermelon, I knew that we were going to be able to solve the problem because, and then yeah, you go. I'm not going to say I recommend making a joke. I seem to have gone quite jokey very suddenly. I don't know what's come over me. Good, right. Anonymous, why are you doing this in Slido chat? My math test was affected by the exam centre due to my access ranges. I ported this on OAT, so you did a special considerations ranking. That goes through the special considerations process and possibly gets assigned there's a process for considering this. If you did the special considerations, it's almost tautological, but if you did the special considerations request, then your request will be specially considered. And it might cause you to be shortlisted for interview even though you have a lower score or no score at all. I think every year people ask me on those bar charts, like, what's going on for the left end of the tail where you've shortlisted some people with really low scores, and I can't comment on individual cases, but we do shortlist people because there was something else going on. Right, dude, you did that in the Slido chat. It could have gone right past. I've missed so many Slido messages. Were they all like this? Oh, right, okay. Okay, right. I'm not going to have a top tip about... So these are like do's. So this say what you're thinking and say what you're about to do. You can ask for help. So let's put clarification to start off with. Maybe ask for help is going to make people like, oh, that sounds like a trap, right? But I would rather help somebody than just have them quietly panicking or something. Like, ask for clarification. Occasionally, we're going to use words that aren't the words that your teacher used, but hey, you can ask us what that means, and we can help. And we won't think that, oh my goodness, how can you not know what a periodic function is? Because maybe your teacher didn't say what a periodic function was. Maybe they did. Yes. So this is like, do ask for clarification if needed. That's not like a blanket. What do you mean, squares? Yeah, whatever. Let's have a you don't. I'm not so at the top there is asking a question at the end of the interview. You don't have to. You can if you like. I tried to say this at the end of the interview. It's not part. You can ask us. For some people, that's a convenient way for them to ask a question that they didn't want to email in, or a question that they didn't want to put in somewhere else. People have put me on the spot about all sorts of things. It's our chance, maybe, to tell you about New College if you want to hear about New College, if you're being interviewed by New College. But I don't need you to ask about New College, and there are loads of other ways to find out about New College. If you ask about New College, I'm not going to think, oh, hooray, a question about New College. I'm going to think, tell them about New College. Sometimes people ask about me, and I think that's... I don't really like talking about myself, but that's me. Which kind of burrito are you? Kindly respond in binary or base 16. You see, there you go. That's an example. Have you struggled with any interviewee who has strong non-native English accent? Personally, no, actually. It's been fine, actually. We have some English language requirements published out there, right, for studying at Oxford, and most people are on track for that, which is actually quite a high requirement, I think, for international students. But that's my hot take on international English language requirements. Right, so I'm going to struggle to translate it into a different language, but maybe I could start defining it in other terms until we realise, the function where x plus L is equal to f of x for some minimum value of L, such that that's true. We can get there. How are students chosen for interview? Oh, we look at lots of things. We look at applications. We look at MAT in particular. We look at GCSE scores where we've got them. We look at your predicted grades, but everyone's got pretty good predicted grades. We look at lots of different things, but we're taking the students that we think have the most potential to succeed. We can use our interviewing resource on. Joint maths computing, same schedule as the thing I put on the screen. They work with us. Right, can I ask you about Laplace transforms or matrices? Only if I am prepared to explain what those things are, because not everybody knows them. In fact, Laplace transforms, my goodness, almost nobody knows what they are, except for the however many people who have told me in their personal statement that they know what a Laplace transform is. Okay. I know that someone I know did do a question about Laplace transforms, in the sense that they were teaching some theory about Laplace transforms. You didn't need to have heard of Laplace beforehand. They designed it so that it was just integration based. It was quite fun, actually, because you ended up knowing about what the point of doing a Laplace transform was. Quite fun. I think there's been a 3 blue 1 brown video. Is that why everyone's talking about Laplace transforms now? There's been a 3 blue 1 brown video. It's not in the scale of mathematics that I think 18-year-olds should know about. It's not really up there, but okay, fair enough. How fair would you say the Oxford admissions process is? That is really hard to define. I'm going to say 9. What's the best question someone has asked me? Genuinely, it sounds awful. I can't remember any of the. So at the end of my interviews, I say, if you've got any questions for us, you can ask us. You don't have to, and it's not part of the interview. And then I guess some people do, but I don't memorize them, and I do a lot of interviews. Right. I didn't write about Laplace transforms for my personal statement, but now I know what they are. There you go. I think you're going to like university. I think you're going to like it. Not because you're going to look things up on Wikipedia, but because you will have other options of ways to learn about new things. What's that 3 blue 1 brown? Right, okay. Should we do an interview question? It's about half past. I think we've done the kind of the meta level of theory of not yet, but soonish. Oxford's going to send some interview invitations to do interviews. We'll say when they are. They are online. We'll try and use online whiteboards when we can. The how has turned into top tips. Mostly they're tutors or default students who have done some training. I'm also here. I guess I'm a tutor. I'm a tutor. That's me. Right. Good. Okay. I think we're going to do a question now. Should we do a question? I think there's always room. I don't think people would believe me if I said 10 out of 10. I think there's always room. 10 out of 10 would presumably be everyone looks at every application and really has a big discussion to make sure we're not missing anything. And 10 out of 10 would maybe be we got more information. But I think we're 9 out of 10, but fairness between candidates at different colleges and things. Maybe that's not what you meant, but Right. Okay. Here's my question that I used a bunch last year. It works like this. Sorry, I've just sprung it on you there. My goodness, I didn't warm you up at all. Right, time for a maths question. Let's go. Works like this. I'd like my computer to calculate the sum 1 plus 2 plus 3 plus 4 plus 5. My computer can only add 2 numbers at a time, and it's expensive to use this particular computer. The cost for replacing a plus b, so it's 2 numbers a and b, and adding those together with the correct value for the sum, c, that cost is a times b times c pounds. So that could be quite a lot. For example, adding 2 plus 3 and getting 5 costs me 2 times 3 times 5 is £30. Because 2 times 3 times 5, it really is 30. And 2 plus 3 is 5. We're going to keep doing calculations in some order until there's only a single number, which is going to be 15, because it's getting the sum correct. But there are loads of ways we could order the operations. And I'd like the minimum total cost. No, people who have been on the Zoom call. Now you see, people found out about the Zoom call as well. So I did this thing with Brasenose and St Cat's. Brasenose, Oxford, St Cat's, Cambridge, where an interview question. People heard about that. I'm doing it again now. If you've seen this question before, then maybe this is your chance to go and make a cup of tea. We are doing the triangle as well, and then maybe I'll try and do something else. The website says 10th, 15th to 18th, and maybe also some for the week before. I think. Interview schedule. Yeah, exactly. So now some people are saying, what's Zoom call? So I did a webinar. I got invited to do a webinar about interviews, and I thought, I'm doing the same content that I'm doing on that live stream. Nothing. Yeah. Plus the triangle question. You want the triangle question at the same time. Right, okay. So the idea for this, by the way, is that we would start this one by getting to grips with what that means. I've put this kind of like notation underneath where some people would start describing what sums they wanted to do, and if they started, I would explain that I've got a calculator and I'm going to do the working out, because I'm not trying to test their ability to multiply, even though that's 1 times 2 times 3. So that step costs £6 or something. But maybe you've got your own opinion about how we should add these things up. We're given the knowledge, we know what sum we are trying to do. We know we're trying to sum 1 plus 2 plus 3 plus 4 plus 5. We can feed those numbers into the computer. And I suppose each time we feed 2 numbers into the computer, we get a number out. So we can feed 2 numbers into the computer, but we can choose which 2 to select to put into the computer. It'll add them together, charges me loads of money. And then we've got fewer numbers, and we keep putting things into the computer until I've only got 15 as a number at the end. And I've spent some money. Good, right, okay, that's the question. I'm going to parallel process it. Let's be weird about this. So while you're thinking about that, this is the silliest way to do the interview one. I've done a few of these, and this is the daft way. Right, okay, so the triangle question works like this. I have a parabola, y equals x squared, and I have points A, B, and C on the parabola. A and C are fixed, and B is somewhere in between. I really like this question. So somewhere in between A and C. So the question is, where should I put B to maximize the area of triangle ABC? So trying to find a really big triangle by moving the point B around to make that triangle really large. Good, right, okay. You don't have to make tea. There you go. Right, parallel process. Some of you are going to think about triangles. Some of you have already seen triangles from, I think we did this at the Oxford Open Day, or at least I put it on the screen at the Open Day and then moved on. That's how I used to do the Open Day. You know, all of this information for the parents and guardians in the room, and some maths questions on the screen for the mathematicians in the room. Who can, you can look up the information on the website afterwards. You've got the internet. Here's some maths. Right, back over here in Numberland. Multiplication of 1 has some impact, of course. So, for example, over here, multiplication of 1. Well, I suppose multiplying by 1 doesn't have much impact, but adding 1 and 2 still costs me money. So there's a suggestion in chat that I start with 1 plus 5. So I'm going to try that out. I wonder what they want me to do next, because this is going to produce the number 6, and it's going to cost me £30. So now I have 2, 3, 4, and 6, and I've got to keep going. Right, okay. Maybe these are rival strategies. I don't know. This one was mine, right? So what next? Let me know in chat how we're going to proceed there. I think I started this interview always by checking people had understood the concept. There are currently like 60 or 70 of you, which is quite a lot. I'm going to try and make sure everyone understands the concept, that we keep adding until we get down to 15. We're trying to apparently minimize the total cost. We're going to add up a total cost in a moment. Let's keep going. Have we got any suggestions of what next? This is a little bit like, lots of people here. Maybe 2 plus 6 next. Smallest plus largest. I can do that. So 2 plus 6. 2 plus 6 is 8. And that step costs me 2 times 6 times 8 is £96. Whoa, crikey. So if you're not sure, I would start demonstrating, and I would maybe explain again that we've got these 5 numbers to add, and we're going to get the computer to add 2 at a time. It can only add 2 at a time. So on a normal computer, of course, you just type this in and it just does it by some sort of computer magic. But this is trying to get one level deeper to say, well, what your computer actually does probably is that it has some machine for adding together 2 numbers. It probably wasn't coded with 3 or 4 or 5 wires going into it, probably just 2 wires for the 2 numbers. And there's some cost for using that machine. And this is an approximation or some sort of modelling problem to say, well, maybe it costs something to do with the size of those 2 numbers and something to do with the size of the number coming out. And maybe it's not pounds, maybe it's electricity or something. I suppose that is pounds in the end. So some people want to use the step 1 as the last one to work backwards. Okay, well, let's try that one on the left. I suppose the left was me, wasn't it? And people want to save 1 for the end. I don't quite know about this work backwards thing, but people want to do this at the end. Oh, sorry, that's gone off the screen. Just there, which will cost, as a final step, £210. So where did this 14 come from? 1 plus 2. Okay, so we've got Aaron's suggestion in chat is the other direction, right? And occasionally I could get the same person to come up with both of these ideas to start with. Maybe we'll save the 1 for the end, or maybe we'll use it. Maybe we'll use it at the start. So some people have seen the questions before, which is a challenge for chat, where people are parallel processing. Okay, I'm going to let people carry on thinking about this. Maybe they're working backwards to say, well, where did 14 come from? I have realised, of course, that with 1 person doing my question, I can use the calculator. With 70 people doing my question, I cannot do the calculator for all of you, which unfortunately means that if you're playing along at home, you might need to do your own multiplication. Maybe we'll finish this one. Let's work backwards on this one. So if I interpret this as being always doing sort of the largest, adding the largest numbers, adding kind of from the right. 4 times 5 times 9 is 180. So this very first step will be to add those ones, and then the total bill here, oh my goodness, 324, 336, 210 is 1050. At the bottom, 1050. So maybe we can do better than that, because that's 4 figures. So over to you. If you're playing this question, that was one idea. It wasn't everybody's idea. It was an idea that I sort of worked backwards like this. In an interview with one person, I would get them to describe that in a lot more detail. It's not really quite possible over chat with the Slido delay, but maybe you've got a different method. Let me know. Keep me posted. Over this side on the triangle question. This is a stupid way of doing it, but I am having fun. Over here on the triangle question, maybe you have started to work out some, I don't know, lengths or angles. because you know formulas for the area of a triangle, right? You know, well, what do you know? I suppose you know half AB sine C because it's on the MAT syllabus, I think. Well, the area of a triangle sort of fact. So maybe you're trying to work out the sine of this angle. That's hard. If you start doing this in an interview, I will try to stop you, politely, but I will try to stop you, because working out sine C is pretty tricky. Maximizing sine CB is an interesting question. So I would try to stop you and I'll try and get you to maximize separately or write down a different area formula. So maybe your area formula next would be half AC sine B or something. And there's also half BC sine A, and actually all of these are hard. They're just hard to work with because angles are tricky when you have three points that are just out there. You might have started by naming some points. You might call this A comma A squared, B comma B squared, C comma C squared. Yeah, we've got options. If you've already done this question, test your understanding by switching the curve to y equals x to the 4. That's a test of understanding. I don't think it's harder. I just want to check. You know, if you've seen this question before and you saw me help you before, then test your understanding. Here's a different curve. So sometimes I did this question and then got a different question. Right. So someone. Okay. So not quite a hint, but maybe some help that I would give to someone is not those formulas. It's quite hard to write this as a MAT question, because if I write this as a MAT question, then you really might try and use one of these formulas. And it's quite hard to write the question to say, by the way, don't use any of these formulas for the area. What? Those are all valid formulas. Why can't I use them? Right, okay. Meanwhile, in money, I think I've seen a suggestion to try from the left. I'm going to carry on this one, I think, actually. So we did 2 plus 3, and then we did 1 plus 5, and then 2 plus 6. We've still got 3 and 4. I think we might do 8 and 4 next. 8 and 4 gives 12, which is £384. And then there's still 3 left over, isn't there? So 3 plus 12 finally to give 15. 3 times 12 times 15 is 540. 30 plus 30 plus 96 plus 384 at the end there plus 540 is, oh, it's 1050. Good, how are we doing? Let's add another question. Has everybody seen the 100 factorial question? I did it last year. I kind of do it every year. Put in another one, because people here have now discovered the real question. Maybe. So somebody said this: is it always 1050? And that's the real question. And it's a question you're asking, but I'm going to mirror that back to you. Good question. Is it always 1050? So in a test, you might just write down, I reckon it's always 1050. But here, we can try and prove that. And I love getting an element of proof into these questions, because if I'm not convinced by the proof, I can ask follow-up questions, which gives the candidate more opportunities to explain their reasoning and to explain what they're thinking. So that something that seems obvious to you, if I want you to say a bit more, I can ask you to say a bit more. There's not a thing for MAT, right? If you type your answer on MAT and it's not really good enough, you don't really get a pop-up that says, oh, you know, tell me more. But in an interview, of course, I can ask more. I'm not sure you did get £900. I think it is always 1050. 100 factorial? Right, we're running a 3 for. Here we go. 3 for the price of 1. The price is free, or possibly £1,050, depending on how you look at it. So this question is stolen is too strong a word, but this question is borrowed with love from Cambridge. I interviewed at Cambridge one time only when I was in Cambridge. Works like this. Well, it's got several stages at the start. So what I might start by asking you, if we're doing it like this, would be something like, is 100 factorial plus 2 prime? I'm not even going to wait for you to type that in chat, because the follow-up is going to be, is 100 factorial plus 3 prime? Quick check. I don't know if this is an international thing, but factorial here, we sometimes use it on the mat. It's in the binomial coefficients, but I would check it interview. If somebody said, what does that exclamation mark mean? Multiply all the numbers from 100 down to 1. So a big product, huge number, don't work it out. Multiply 1, 2, 3, 4, 5, all the way up to 100, all of them together. No, it's even. And this one is threeven. Sorry, threeven's not a word. It's a multiple of 3. Multiple of 3. Okay, keep going. How far can you go? Is 100 factorial plus 37 prime? That's the number in the thumbnail. Right, good, okay. Give them a moment to try that one. People on the computer question, you've maybe started writing down loads of algebra, and well, that's probably quite messy, so probably I'm going to interrupt and say, do you think it's true for other sums, maybe? Should we check some other sums to see if it's true for other sums? Because some candidates think that it's a special fact about 1, 2, 3, 4, 5 being added together, and some candidates just intuitively guess that it's true for other sums, so I want to get everyone there. In fact, it's true that it's true for other sums, but I want to get candidates there by kind of asking, should we try it? Let's find out. Because yeah, it's kind of good, because you can kind of force people to realise that they don't know, and they should try and find out. In particular, if you're trying this with algebra, I would say, what happens with 3 numbers being added? So if we had numbers, maybe we call them A, B, and C. Maybe that's not a great choice because they're already in the question, but whatever. 3 numbers, A, B, and C. There's several different ways I can think of adding them. There's several different ways I can think of adding those together with this computer. Maybe it always costs the same. I mean, maybe it costs £1,050, £1,050. Maybe it costs that much every time, but maybe not. Right, numbers people have got to 100 factorial plus 100. These are all no. So this is 99. Let's do a sentence. Do a sentence? I don't do interviews for English language, I'm afraid. Let's do a sentence. We have 99 consecutive numbers. Oh, that's no, that is spelled correctly. There we go. Consecutive numbers. None of them prime. And I'm going to put some extra caveats in there. Positive whole numbers, right? And consecutive means in a sequence that's increasing by 1 each time. Plus 2, plus 3, plus 4, plus 5, whatever. Okay. Is there a set of 99 consecutive numbers with exactly 1 prime? So here's a set of 99 consecutive numbers up to 100, but not plus 1. I don't think about that too hard. But here's 99 numbers. Well, you can think about it if you like, but you know, it's a multiple of 1 is the obvious thing to say, but that's not really saying anything, is it? Is there a set of 99 consecutive numbers? And again, I mean positive whole numbers. Oh, this is going to belong. This belongs over here. Consecutive positive whole numbers, just in case, with exactly 1 prime. That's your question. over that side. That's significantly harder than the previous parts of the question. That is sort of the idea here. I will come back and help you, but I need to know what you're thinking. I know that with Slido chat, the thing up here is that people only want to put things if they're very confident about them or if they're anonymous. I think that you can switch to being anonymous if you like. I know that some people have usernames. I think you can switch. Why have you done this already? I do this every year on the live stream. If you've watched a previous YouTube video, you might have seen it. It's also been used by, I think it's been used by other people on YouTube as well. I think someone told me once that Tom Rocks Maths has used it in a video. Or possibly someone else who's interviewing for Cambridge, which would mean they're still using it, which is probably not a good idea. And I feel a bit bad for having put it on the internet every year since then. Tech issues. So tech issues, if you did the special considerations form, then if you made a request for special considerations, then we'll consider the request for special considerations. I don't know about 100 factorial plus 101. This is good, right? Because in a written test, you would maybe write 100 factorial plus 101, and you would maybe say that's prime. And I would say, is it? Right? I don't know. I don't know if that's prime. Maybe it is. Maybe it isn't. I can tell you it's not a multiple of 3. It's not very good though, is it? Right, okay. No, because of even numbers. I want exactly one prime, not exactly one not prime. I'm sort of not being that greedy. Right, where are we going? Geometry question hasn't happened for a while. Geometry question, maybe you've realised that the area of a triangle could be written as half base height. If you cast your mind all the way back to the very first time you learned about the area of a triangle, you will want for this to choose a nice steady base for your triangle from which to measure the perpendicular height. Now, of course, B is moving around, so these two sides connected to B are constantly changing, but there is a nice solid base. It happens to be on the top of the triangle, but if you turn your head round, then you can imagine this to be the base of the triangle. I don't think Miro has a rotate option, so I'm not going to... Oh, it does. If you turn it round, then you have a nice solid base of the triangle there. Nice solid base of the triangle. And then the question is about moving B around to maximise the perpendicular height, the perpendicular distance away from that fixed line. Right, there you go. So keep going until you find a prime. Right, there we go. Can we ask the interview to prime factorise 101 for us? 101 itself is prime. 101 is prime. Okay, they've got half base height. They've got an idea about bases now. I don't disagree that 101 is prime. I think the question that I wanted to sort of pose there briefly was 100 factorial plus 101. That might be a multiple of 7,067. Don't know, it might be. This definitely isn't, that definitely isn't, but if you add them together, then as far as I can tell, all bets are off, right? So maybe. Maybe is not a great answer to this question, but people are now saying that you could keep going until you get to a prime. Keep going up until you find a prime. Which is a good moment for us to have a quick discussion about why there are infinitely many primes. We are relying a little bit on that fact, I think. Unless you happen to know a particular prime number that's bigger than 100 factorial, then you're, I think, relying on the idea that there are infinitely many, probably. So you're going to add something on. Good. Okay. Right. Keep going until you find a prime. That works. That's good. I am using a stylus. I have a very cheap tablet thing that I got during the pandemic. It has held up remarkably well. It's one of those graphics tablets that doesn't have a screen. It's the thing that makes the scratching noise that plays all the way through the live stream. That's not like a... I've been told it sounds like I have a sort of small gerbil or something on my desk, but some sort of small animal, but that is the scratchy sound of a stylus that has never had the nib replaced in 5.5 years of, oh gosh. Okay. It's done a good duty. Next question, is there a set of 99 consecutive positive whole numbers with exactly 2 primes? The handwriting got a lot worse there while I was talking about the handwriting. It is not a whack-on, although the second one that I got for myself was a whack-on, just a small one. If you represent 100 factorial as a gamma function, then my follow-up question is going to be, what are you going to do with that gamma function? Now what? I mean, you can. It's, what is it, gamma of 101? I forget how that works, but don't know. Now what? You probably return it back into 100 factorial, right? Or you could go the other way. Going the other way also works. You can go up, you can go down. Going down, you need to use the theorem that there exists a prime number. No, there exists a prime number, so you'll be fine. Is that why somebody said 67 in chat? That's not why somebody said 67 in chat. Right, okay. We haven't talked about the computer question for a while. Let's check in with them. So I'll just put it on the screen again to see how's it going. I left you thinking about what happens with 3 numbers, and I think I might do that calculation on the screen in a second. Let's read chat. What are they up to? The theorem that there is a prime. Yeah, it's like before Euclid proved that there were infinitely many primes. Actually, ancient mathematicians have known that there exist finitely many primes, or at least finitely many, because they had some. I'm not putting a 4th question up. We have 3 on the go. 3 is feeling like too many. I feel like I'm neglecting the middle one. Yeah, good. Ben and Sophia, hello. You get the same thing when multiplying and simplifying. Can we extend it? Yeah. Whoa. Okay. 2 people have got theories about finding 2 primes. I've seen lots of people do different things. How to prepare. I honestly, so preparation I think might be practice talking about maths a bit. So if you've got a maths question, it doesn't really matter whether the person you're talking to knows what you're talking about, but practice talking about what you're doing or what you did. I think it helps you with your own awareness of what your problem solving was like. If you look back at the question you've done and just talk out loud about what you were doing while you were doing it. If you're stuck, try saying what you would do next. If you can get a maths teacher or someone to prompt you about what to do next, maybe, perhaps with a MAT question where if there's a MAT question that you haven't done but they've got the answer, then maybe they could prompt you about how to get through the MAT question quite quickly. That requires them to have looked at the solution of the MAT question and understood it, and it's quite hard actually to prompt people through. So I'm not expecting, it's a skill that we train people for. It's sort of difficult. Right, can I add a dislike button? There is actually an option for dislike. There you go. Pretty sure I've turned it on. There you go. Because it's the last one, I'll switch on downvotes. They don't appear on screen. Do I have to refresh? Oh, yeah, popular recent. There you go, they now go, things can now go negative. Right, there you go. Chat, we did it. Oh, and I also broke a thing. Right, technical issues at 6 o'clock. Remember, if you, there we go. It's 6 o'clock. If you've been looking at the screen for the last hour, remember to blink, remember to look away, remember to look at some maths. No, that's not one of them. I'm going to drink some water. Right. It's quite hard generalizing from 3 things to 5 things. If you've written down A, B, C, D, E, I would probably interrupt. I would instead tell you a quick anecdote about how I find it easier to go to 2 things. With 2 things, it costs, and then we know this is like, this is a little bit silly, but we know what the sum is supposed to be. It's supposed to be A plus B in brackets or something, like a single number. So with 2 things, it costs A, B, A plus, oh, I'm onto chat. a plus b, which is a squared b plus ab squared. And then the kind of prompt is, where have you seen that before? I'm quite pleased with that prompt because it's really not like a strong hint. It's not very leading, but it does lead to, I think, the right intuition for what's going on here. It does help you get to the kind of the mechanism behind the scenes for, I guess, the question of why is the computer like that? What's it doing? Same to you. So there's a thing to understand here about where have you seen that before? What is actually going on here? If I write it out as a plus b rather than abc, what is going on there? I briefly had it set to popular instead of recent, and somebody's found out. Anonymous though, most likely to comment. Ooh, turns out I highlight things negative. Oh, right. Look, it doesn't show it. Just is that displaying on there for you as well? It just says less than 0. It does not show like how much. We've enabled downvotes. Fun times. But then in my admin panel, and Callie, can you see this as well? Callie and I can see how many downvotes things have got. Oh, that's fun. So if you downvote something that's already been downvoted, I've never switched this on before because I thought it would only lead to trolling. But if you downvote something more than 1, only Callie and I get a little counter for that. Fun. Okay. The number of downvotes was 6. Then it was the number after 6. You can see it, yes, Callie. Right, are we having fun? Oh, right, okay. Have they answered this question of where have you seen this before? Is there such a thing where you're too good at maths and you never get stuck? Nah. If you're too good at maths, then I would expect, I don't know, my wildest dream is that somebody has this idea. I think that's unrealistic, especially in the time available for somebody to work out what's going on and kind of do the question the efficient way, especially because I am, in order to make sure that we don't lose time, I am spending time at the start to make sure they've understood the question, which naturally leads people towards actually calculating. And you have to discover the real question that's hiding behind the scenes. Because the question is phrased as how to minimize it, and then you start to suspect that you minimize it by doing anything because it's constant. In my wildest dreams, a candidate will then say, well, maybe we should find out what's really going on here, and then somehow work it out. I think I said this to... They'll get in touch with me if this is not true, but I think I said this to everyone who I interviewed for this. Everyone who I gave this interview question to, I think we ended up going back down to 2 things. We saw that expression, and I said, where have you seen this before? Because I need to make sure you don't see it too fast, right? Could you do... Yes, you could. Right, okay, and chat in square brackets. There we go. Thank you. Cubic. Yeah, cubic. Binomial expansion. It's missing the 3. It's got stuff going on. This expression is, and I like this way of writing it, a plus b cubed minus a cubed minus b cubed all over 3. And I think that's good. I would then get people to say that in words to explain what that means, and then we would go back to 3 things and say, you've got this expression for ABC, can you find something like that? Well, what's going on, right? When you add a plus b and then add c, can you use this new formula? It's not as tidy as a times b times c down there, look. That's very tidy. It's not tidy, but it is easier to work with. So can you work out what was going on if you write it out like this, not like that? What's happening? Right, primes. What if you've never seen this before? Oh, you're not supposed to have seen this before. This is oh, you have seen this before. This is on the MAT syllabus, right? This. Eventually you'll say something about cubing or multiplying a's and b's together. We'll get there. But you really have seen a plus b all cubed before. I'm sure you've worked it out yourself, I'm sure, when once you've seen that a plus b squared, is this a universal experience? Once you've seen that a plus b squared is not just a squared plus b squared, but in fact has like a secret extra term that you would never guess, plus 2ab, surely it's a universal experience to be like, oh, I'm a qubit. What comes then? It's not just a cubed plus b cubed. There's some magic extra stuff, right? The true fact is out there. And then at some point you learn about Pascal's triangle, right? And you learn that there's a way to predict what's going to go on without having to multiply everything out, and that's called the binomial theorem, which is so exciting that it's on the MAT syllabus. I feel like that's an experience that I think people have probably had, or at least they've seen the binomial theorem. Not a squared plus b squared, Ruben, right? Okay. Are you going to do any new questions? I want to eat dinner. There is pressure on me to do a fourth, but we've got to wrap some stuff up. Right, so base times height, people. I don't know if there are any of you in chat, but maybe you've realised that you want, if you draw on these like lines for, oh, I've done quite well here actually, because look, each pink line that's parallel gives me examples for what the height might be. That's like a height chart, height away from the base. If B is somewhere on one of those lines, then that gives me, well, then those are the points with equal height. They're kind of the ladder of how high up we are away from that base. So drawing parallel lines. And I can make this extreme by finding the line that's tangent. And I've never really got this one to work on the YouTube live stream, because ideally I want you to say some of those words. I'm saying too much, right? I should shut up and listen, and get the candidate to say some stuff about extremizing this by, or maximizing it by pushing it away from the line and just getting a single point, so a point of tangency. And then we know loads of things algebraically, and now it falls apart and becomes an algebra question. And you can do algebra questions. Right, good. That pretty much ruins, well, not ruins this one, but finishes that one. This one, the way you generalize this, so for two things, the way you generalize this is kind of amazing. If you were then to add c, the cost for the next step would be a plus b plus c cubed minus the cubes of the things that you were adding. So the general rule here is that the cost is cube of the new thing minus the cubes of the things that you had before divided by 3. So if you do this first and then you add on c for this like 3-step that we talked about briefly, a plus b plus c cubed minus a plus b cubed minus c cubed. Not quite just a straight substitution, but same rule. And brilliantly, if you add these, there is some cancellation, where this cancels with this to leave you just a plus b plus c cubed minus a cubed minus b cubed minus c cubed. And that's brilliant. And then that gives you kind of the final answer should be that the cost is always, because of that cancellation, the cost is always this, when you add up all 5 numbers. Which is why it's always 1050. Somebody likes it. Thank you, Anonymous. Test your understanding. So test your understanding is, what if I get a cheaper computer? I think this is cheaper. What if the cost is just a times b? So none of this times c business. What if it's just a times b? Random and amazing. There you go. Random has got more votes than amazing. Okay, so that's called an invariant. If you want to look up other problems that are a bit like this, but not really much like this, if I'm honest. Invariants are useful in mathematics because if you can find something that's not changing while everything else is, then you've got a handle on the problem. If you can find something that's not changing while everything else is, then you've got a handle on the problem. Oh, sorry, back over here. If you can find something that's not changing, then over here it's something like the... what's not changing? Is it the sums of the cubes of the numbers you've got? Yeah, it's invariant as you go through this process. Fair. So you can look that up. The Oxford Student Society here is called the invariance. because finding invariance is important. This doesn't prove that all combinations lead to this. Right. So you're right, we haven't quite proved. We've proved that if you start from the left, then you will get this sum. And then there's a symmetry argument to say if you permute the 5 things, so you have maybe a machine that will add them from the left. That's a weird motion to do, isn't it? A machine that will add them from the left, but you can still choose the order that you line them up at the start. Addition is commutative. So you can take your 5 things at the top and shuffle the order before you put them into such a machine. Well, that's symmetric as a result at the end. So it means that if I put in B, C, A, D, E, or something like that, so if I shuffle them around a bit, then, so I'm adding B and C first, then I will get B plus C plus A plus D plus E cubed minus, and then each of the cubes in a different order, but it doesn't matter. So because you can shuffle the order at the start, and this answer allows you to permute the letters at the end, it's all okay. Request to finish the parabola, and then we've got to finish the primes question as well. So algebra time. Parallel to AC. We want a line parallel to AC. Tangent to the curve. So what are we going to do? Well, we know the gradient of AC, which is this, and we want that to be equal to 2 times x for this point x. In fact, I'm going to sub in b. I'm going to say, so I've differentiated x squared to get 2x, sub in b for the coordinate here, I was calling that b. And then it's quite nice because this cancels a little bit. Difference of 2 squares means that this is just, b is just the arithmetic mean of a and c. It's in the middle, that's the answer. Which is actually another reason why I can't do that as a pen and paper test, because too many people would just write down, I don't know, it's in the middle. And I wouldn't know if they'd done anything worth any marks or not. You know, we just write, come on, it's just in the middle. Like that person in chat ages ago who put a plus c over 2, and I thought I'm going to ignore that because I don't know whether they've seen the question before, if they've immediately done loads of algebra, or if they're just guessing. And I don't want to, I suspect they'd seen it before. Right. Ooh, is that how you're vocal? Oh, okay, I'm learning today. Good. Parabola. If you try this with different curves, the algebra is a bit more difficult, but not a lot more difficult. So I reckon you'll be all right. This gives you the difference of 2 4th powers, I think. Is that true? Yeah, I think it gives you the difference of 2 4th powers. There's a cube on the other side. It's kind of fine. Difference of 2 4th powers you can handle. It's also the different 2 squares. Right, and primes. So occasionally people, when I've tried this question, have told me, yes, keep going up until you find twin primes, primes that differ by 2. And you say, oh no, we don't know if there are infinitely many twin primes. So I don't know if there are going to be infinitely many occasions where you find 2 primes together. And also, worse news, what if those twin primes are actually surrounded by a constellation of even more primes? So that even once you've found them, oh no, it might have some other primes around, so that it's not exactly 2. There are these other ones on either side. Further away, we're expecting the twin prime on the side, but then twin primes on their own, but others. So yeah, so Ruben says keep going until you find a prime after you find another prime, but the problem is as you're searching, you might see a prime and then lose that one before you gain another one. So the question, I suppose, is if you keep going that way, and then could you ever get 2? And sometimes people would tell me something vague about the gaps between primes getting larger, but that's not known either, because such a fact would rule out the existence of twin primes, and we don't know there's not infinitely many twin primes either. We don't know either way. But moving down, so moving down towards 0, that works because, well, it's not just that there exists 2 primes, but we know there's lots of primes quite close together down there. Let's try and make that argument more precise. I kind of want someone to tell it back to me. Ideally, someone who hasn't seen this before. I've done this question every year for, well, I suppose it's everybody's first year. It's everybody's first. It's my last MAT live stream, but it's somebody else's first live stream. Hi. The argument that I'm trying to get towards is something like, here's an interval with no primes. If I move all of the numbers left one to smaller numbers, well, that's left for me, isn't it? Yeah, I go left one, then I'll have 99 numbers. They'll be slightly smaller. Maybe I've got a prime or maybe not. I'd like to keep going until, well, eventually, there are loads of primes down here somewhere. I'm looking, well, I'd like to know, is there a set where it's exactly 2, the number of primes that I've got? It's the last one because it's the last one on the calendar. Means it's the last one of the year. There exist 2 primes. And you know, just the theorem there exist 2 primes wouldn't be enough, because as I move down, well, you see a prime, but maybe it's gone away by the time you get down to the other prime. So the fact that you know lots of primes that are close together is kind of important. Yeah, so if you keep going until you reach the same prime, you might see one and then lose it, and then see another. And the fact that 3 is prime, 1,003 is prime, that kind of that's just too far apart. All the primes underneath 99 multiplied together, so 99 factorial, or just the primes, apart from one prime with value greater than 50, then there's a gap in the 99 consecutive numbers. Well, is it exactly 2 primes though? Because there's some other numbers in there, right? All primes under 99 multiplied together, apart from one prime with value greater than 50. It's not obvious to me that any of those numbers are prime. You're talking about huge numbers there. 2 primes with a difference lower than 99. Well, is that good enough? Again, I'm worried that those 2 primes that are quite close together, it's not obvious to me that there isn't a third one in the interval. I would like exactly 2 primes, so 2 that are quite close together, but maybe they're very close together. Maybe they only differ by 37, in which case maybe there's another one that differs by more. You said to keep going until I get to ones that differ by not very much, but maybe there's another one which differs by more, but in there as well. I suppose you say less than 99. The first 2 primes where the gap is, does that work? Gap is less than 99, because if there's a third in there, then that gap would also be less than 99. So you should have gone to that one instead. Maybe that does work. Okay, I think that works. Does that definitely exist? Well, there are some primes where the difference is less than 99. There's some where it's not. So in between, there's a case where it was like the last time that it happened. Finite interval. Yeah, sure. I'm having that. Good. It's not what I thought you were going to say, but yes. Good. I liked that. That felt novel. I felt like I talked too much, and I read one chat message and then talked too much. But yeah, okay, cool. The formulas are hard. From 1 to 99, there are 25 primes, and you can only go up or down 1 prime at a time. Yeah. So as you move, 3 things might happen. Kind of 4 things might happen. You might gain a prime. You might lose a prime. At this, you might gain a prime. What am I saying? The proposed shift is something like, oh dear, let's draw this. The proposed shift is that we shift left one, in which case you might gain a prime, it might be a non-prime, and simultaneously over here we might lose a prime, or it might not be a prime, so I don't care. That last one is don't care. So my emotions about how many primes we've got, right? We might gain one, we might not, we might gain one, we might not. And then, sorry, I've got to lay it out carefully, haven't I? So then there's the other cases that we might lose a prime. I'm trying to do all 4 combinations. Or we might not care, we might not care. And in that first case, we gained one and we lost one. So overall, don't care, that's like plus 0 for primes. In the second case, well, I didn't gain one, and in fact I lost one, so the number of primes has gone down by 1. In the third case, we gain a prime, and we didn't lose one over here. So we actually go up by 1. And then in the last case, true neutral, we didn't gain a prime, we didn't lose one. So no one minds. But the number of primes can only go up by 1 or down by 1, which means that if it goes from 0 out there at these huge numbers on the screen, 0, all the way up to like 20 something, when you have small numbers, then at some point in between, it's only going up or down by 1, it can't skip 2, so it can't skip the number 2. Good, right, fun, okay. Let's do some Q&A. I think that's the right way to go. We've had 3 interview questions in parallel, which was a fun way to do it, if not maybe the most effective way. But, you know, in a real interview, I would only do 1 question at a time, but I'd only have 1 of you at a time. So maybe this was a good way at splitting the audience into separate activities so that you weren't all doing them. I don't know, there's something in this, right? Give you 6 questions, maybe multi-screen, see what happens. Next year, twice as many questions. Don't hold me to that. 6 questions. Off we go then. Choose your question. I mean, that's not how interviews work though. I would never like throw 6 questions at someone. Right. If we don't get interviews, are we disadvantaged for applying to study Masters at Oxford? No, we will, in the nicest possible way, forget all about your application. We don't even link them if you were to apply for undergrad again. We don't connect applications together like that. And I mean, I do talk to the people the people who do masters applications. They are in a different office, and I talk to them like in the kitchen, but I don't talk to them about applications. You're welcome to apply for masters. Oh, the end of the computer question. Yeah, I didn't quite finish that. Can you show how any permutation of 5 can correspond to 1 sequence building from the left? Yeah, sure. Okay. I do want to change the layout. I'm just trying to change the layout a little bit. So one way of adding is like this. Okay, which is a plus b plus c plus d plus e cubed minus a cubed, b cubed, c cubed, d cubed, and e cubed, all over 3. And then a different way of adding them is to rotate them first and then add like this. So this is adding them in a different order. I suppose I need to go one better, don't I? So I let people do this in the interview, and I'm now remembering that actually it's a little bit harder than that, because you might do a branch. Thank you for doing this. I didn't hold people to this in an interview. You might add a pair and a separate pair. My dream for this really, which I shouldn't talk about dreams too much, my dream for this really, which I didn't really hold people to in the interview, would be that we would actually talk about how the computer assigns a value to different numbers, to different inputs and outputs. So it's sort of taking your raw materials, the numbers 1, 2, 3, 4, and 5, and it's charging you for those raw materials when you use them. But the value of intermediate products always gets cancelled out when a number is produced by a process in here. So as the computer adds, whenever a number is produced, like 9 or 5 over here, whenever a number is produced, it will later be consumed unless it's the final answer. And the production involves a term that is plus the cube of that number over 3, like this a plus b cubed, whenever it's produced. And the use of a number, whenever it gets consumed, has a cost associated with it of minus that number cubed over 3. That's where the separate terms of this expression come from. The positive product, a plus b cubed over 3, and negative, the inputs, a cubed and b cubed separately over 3. And because we're going to keep going until we get to one single number, every intermediate thing we produce is also consumed. So every time we have this like plus 9 cubed over 3, we also have at this step here, where the 9 is being used, we have minus 9 cubed over 3. Plus a new product, which is also doomed until we get to 15 cubed over 3. So you can tell the story to say it doesn't matter how you combine them together, everything you produce along the way, whether you did it in 2 pairs or as a separate snake of numbers, doesn't matter, anything you produce will be consumed until you get down to the final answer. Cool. There's more prime stuff in there. Let's have a look. yes, I don't think any maths or joint honours or maths and philosophy or computer science and philosophy interview invites are going to go out before Monday. If a college is really prompt and if some admin processing happens extraordinarily quickly tomorrow, then I guess technically Friday tomorrow, but I don't think that's, I'm not even going to say that that's going to happen. And then it can be a nice surprise if it does. Right, okay. Lower bound is not the one I often get asked about, an upper bound, right? Where we try and give people a week's notice for interviews, but we're better than that usually. Are maths and CS shortlists created together or independently? Together, we work together, but we have separate intake numbers for how many places we've got, and we have separate shortlists. We consider the applicants. What do you mean? Together or independently? We consider the shortlists separately because they've applied for different courses. So we look at the applications separately for the courses they've gone for, but we work together and we say, we have a spreadsheet that's got everybody in, right? But we know they're applying for different courses. What does it mean if you get your invite earlier? Thanks for shouting. That got my attention. It means that your college sent the email out earlier. There are 29 different colleges that admit for maths, and they are each responsible for emailing candidates. They don't all do it at the same time because there are 29 people pressing go on emails. It doesn't mean anything about you. It hardly means anything about them. Good. Number of applications. Have we published this? I don't think we've published this. It's not an unusual number of applications. I'm not going to give a number, but it's not. If I told you the number, you would immediately lose interest. We publish the number every year. You can look at previous years. Do interviewers prefer logic to something like calc? Interesting question, isn't it? What have I done? I've done a question with a bunch of logic. I've done a question with some calculations. I've done a question with some calculus, if that's what calc is short for. Why does the MSc? I don't do admissions for master's courses. I definitely don't do course fees for master's courses. The mathematical and computational finance one, £50,000. That's the mean math score. I'm definitely not doing mean math score, sorry. Any college is harder to get into? My friends keep telling me I've applied to the hardest college to get into for maths. Each year, some colleges have more applications than average. There are maybe some patterns, but it's a bit transient. It changes. For most colleges, their number of applicants changes year on year quite a bit. I would not be comfortable advising applicants based on those numbers because it changes how many applications they get. And also, we have lots of processes to make sure we're taking the best students overall. One of those is the second college interviews that I talked about, where, I didn't write it on the board. I zoomed in, there's nothing there. The second college interviews that I talked about, so that if a college does have lots of strong applications, then sure, just mathematically that means that there's more competition for places at that college, but good students who have applied to that college might get taken by other colleges instead. And that means that overall, I'm pretty sure it's fair, so that whichever college you've put, maybe you'll get that college, but if there are 20 people who deserve to be at Oxford and they've all put that college, then there isn't room at that college. So maybe that's what your friends meant by hard to get into, that they looked at some ratios or something. But that's not the end of the story for those 20 people. Some of them in bedrooms at that college, stay at that college, accommodation in first year at least, and either third or fourth year usually. Anyway, whatever. Check the colleges for accommodation offers. Anyway, whatever. Colleges where you live in first year, maybe some other years, is an important part. But lots of them get offers at other colleges normally in that hypothetical situation. Which then, this is a weird effect where once they've made friends at their new college, once they've got to know the tutors at that college and done some maths with those people, they sometimes realise that they were at the best college after all. Yeah, okay. Thanks, Steve. So numerically, Worcester and St John's I think, got the most applications last year. I don't know how that's supposed to affect your decision making this year. Like if you want to study at Worcester or St John's, then you kind of put those down on the form, and then if you're strong but they don't pick you, and this goes for all colleges, if you're strong but they don't pick you, then second college. Will the interview be friendly or put on a harsh approach? That's a good question. I try to be friendly, but I am also trying to ask tricky maths questions, which some people don't enjoy at all. So I try and do my best. We're not trying to scare people. I am getting mathematicians to do these mostly. Am I getting to these? Colleges are getting mathematicians to do these mostly. I don't employ them. I'm certainly not paying them. Colleges find interviewers. I think harsh approach is too much. Should I do maths if I am scared of competition, or apply for a less competitive course like engineering? Well, hello. I think you must be applying next year or something. So welcome to Oxford MAT Livestream. I said it was the last one. I meant this year. I have bad news about engineering, but let's save that, because I think doing a course that you want to do is probably more important than doing it at your absolute top choice university. I don't know, maybe I'm wrong about this, but I think if you want to do maths, then turning up to engineering practicals and doing all the engineering certification and learning about material stress compounds, I just worry that you won't like it. And however competitive it might be for different universities, at the moment my belief is that across the sector, if you want to do maths and if you've got good grades, then lots of universities will take your application. Right, okay. Are we going to be increasing the places? There has been a rise in the number of computer science tutors at Oxford recently, which has led to a rise in places for things like maths and computer science and or computer science. It's a bit hazy on the two of those at the moment. So yeah, the number of places has been going up. Not quite as fast as the applications over the last 15 years have been going up, but we have now got a bit of motion on that. I believe that, which college is it? Is it Wadham? I think Wadham is offering computer science this year, having not offered it before. There's like the number of colleges offering computer science is going up, which is kind of exciting. They're now at, I think, 26 doing some varieties of maybe just maths and computer science, but 26 out of the 29 that do maths. Pretty exciting times. Plus applying next year, remember, check the list, right? Numbers true as of 2025. Right, good. Okay, I'm going to scroll a little bit. Shall I look at top questions? Let's look at popular. Quick look at top. Oh, look, it's Steve at the top. Bound. Still no leaks. Ah, bless them. Still no leaks. Oh, sorry, Eric. So random. This was a different person before. This was a different person. They're changing their username to be anonymous, but with different usernames. Timur advice. You come to the MAT live stream, you get advice on TMUA. There you go. How should you get a formula? How should you generalize it? This kind of sticking together. We now had a couple of looks. I haven't told you the answer for A times B, but maybe you've started working out some expressions and seeing, where have you seen AB before? The expression AB before, we saw it was something to do with cubes. Have you seen anything to do with squares that involves AB? Will the interview have any further maths content? Could do. Last one, I missed these. That was Timur. Do people say Timur or TMUA? I say both. Matt livestream, come to the official Oxford place, and you're like, let us know what's going on. Oxford should build a new college. New College 2, we should call it, for undergrads. The number of applications keeps increasing. Yeah, I'm not opposing that. Sounds great. Sign me up. Yeah, sounds good. That's what I say. Timur. Like this. Okay. Like it's short for the. Yes, okay. I say Timur. Yeah. Timur. That's got a Greek letter in the middle, hasn't it? That's fun. Okay. TMUR. Ooh. This is fun, and we've now entered the phase where James is reading out chat messages without thinking about what they say. So I'm going to stop doing that. Right. Okay. I'm running out of content, I think. I'll show you an interview question that I decided in the end it hadn't gone that well. Partly to give you the context that we're interviewing people multiple times. Not all of them do I learn something. Sometimes I do an interview and I decide didn't really learn very much there. There was a few years ago where I did a question and I wasn't very happy with it in the end, in the way it went. I guess I'm doing this so that you know that, well, obviously you're trying to do well at things in your interview. In some sense, so am I, when I'm coming up with an interview question and then using it on people. And because we're interviewing multiple times, there's this effect where it's not the end of the world if I take a risk and it doesn't really work out. Maybe I'm saying this so that if someone has a terrible interview with me in the future, they can be shown this clip of video and say, well, he's probably screwed up again then, hasn't he? That's probably just about him, not you. Right, here's the question. I wanted to ask people about an eclipse where you have maybe a moon that is smaller than the sun. You know, famously, our solar system, the moon looks the same size as the sun, so it tends to block out the whole sun. But there's this thing in physics where you're looking at the light you're receiving from a distant star. Maybe we'll colour this in. A distant star as something moves past, some sort of moon. And the light that you get from that star dips because the moon has got in the way until eventually it leaves. And the question was, can you sketch a graph, please, of the amount of light that we get from that star? You know, it's there, and then it's down a bit, and then it's up a bit. So people would draw something like this, and then they'd join the dots to make this kind of bathtub shape. I think some people even do this in physics or something. So already people thought this was a bit of an odd question because I think some people in physics draw this. And oh look, IPA. You can't do diacritics. You can't do the corrupted text. If you've applied for a joint honours degree, oh, hang on, there are serious questions going on. How is second college chosen? Random algorithm. Don't overthink it. We use it to kind of move people around based on how many applicants there are at different colleges. It doesn't mean we don't take into consideration your preferences. Sorry. Apply for joint honours degree. If it involves philosophy, then you might expect some philosophy interviews as well as the other half. If it's maths and computer science, then they might be combined together or they might be separate degrees, separate interviews. I'm not doing the convenience. Does this with two squares? Oh, one is rotated 45 degrees. I do the graph. Anyway, the thing I wanted to do was to talk about the shape here at the corners where it's not actually sharp. Now, unfortunately, actually doing that calculation involves thinking about the area. We've done this, I think, on the show before, the area of intersection between two circles, which is really difficult. It's one of those calculations that I think I got everyone to do in the MAT Livestream earlier, where we had, I think, two equal-sized circles, and that was hard enough. They were nicely spaced as well, but still finding that area in the middle was tough work. So I gave people a kind of different question. And the thing I think I was unsuccessful in really was in convincing people that this was at all the same question, where related at all, where from the side view you could imagine that this is if the moon is much smaller. I'm going to set them back to being sun and moon. If the moon is much smaller than the star, then you can approximate this situation with a straight line for the sun and a parabola for the moon. Where the moon moves up and down. And then you can find the area by integrating that parabola. So we would set this up as like x squared over a, perhaps, for this kind of shape of that kind of curved section of the moon like this. you can sort of approximate it with a parabola and approximate the sun with a straight line. I don't think I did a great job of convincing people this was a sensible thing to try, but then we would do the sum, and then we would get a result, and that would tell us some area, and then the challenge is to remember what we were doing and what I want that to be. As a sort of halfway step, people often had to draw the graph of x to the 3/2. I've set the pen to be comically thick. Comically thick is also the act that I'm doing sometimes for talking about how not to do questions. Anyway, I have to sketch the graph of y equals x to the 3/2 because that's the answer. The way it curves in is like x to the 3/2, but reflected twice or something. People were surprisingly bad at this. I'm never going to do this question again, but you might like to think about how to sketch x to the 3/2 because people were surprisingly unprepared for doing that. I like a graph sketch. I'm never doing this one again. You might like this. I prefer the expensive calculator. Me too. The expensive calculator was fun, and people actually at the end felt like they'd done something. Whereas this one, they kind of drew it right the first time, and then I went, yes, but what if this was a strange technique for discovering exactly approximately what the corner, like, I know it's a good approximation, but I never really convinced anyone it was a good approximation. So, oh well. Did I do straight edge? I might have even done 2 parabolas, which would be a bit insane, but this star step is also a parabola. That's a bit silly. Right. Maybe just x squared plus a? What did I actually do? I did not love doing this question. Anyway, right, good. Okay. Did anyone apply for Oriel? There we go. Yes. From my side, I can confirm, yes, some people did apply for Oriel. How do you make sure you ask a question that candidates might have seen before? I try to invent my own things, or remix things, or just disguise things, or make things weird, or mash 2 things together. If I ask something that I think people might have seen before, I ask them to tell me at the start. What's my favouriteest interview question of all time? I mean, currently recency bias, but I do think the calculator one is strong. I haven't really done the debrief, right, where you get to see people form the hypothesis, form the idea. There's this moment in the interview where they realise that maybe it's the same every time, which is nice. And then we get to sort of prove it. I have to help, but there's some stuff going on about how you might try and prove it. I get to see them do some algebra, so I get a bit of a sense of, have they ever cubed a plus b cubed? Have they ever done that before? If not, I'm a bit surprised, but you know, get to know how much familiarity they have with some core content, a bit of core content. And then, depending on how much time we've got, we get to get into this kind of like, why does that always work? The kind of in words description of what's going on. Let's not use the phrase word problem, but this starts as a block of text that you need to interpret. It turns into algebra, and then by the end, I would, if anything, quite like some description in words about what was really going on all along. Turn it back in. What if you have seen it before, please say. And then we'll switch to something else. Yes. Right, good. Okay. Right, and you shouldn't be people using the downvote for subject or college. That's rude. This is why I don't do downvotes. I'm switching them off again. We're just being mean. And we mean mean to the philosophers. They will, you know, they have the power to cause things to exist, right? They say, I think, therefore I am. So maybe they also have the power to make you am not. Right. What was really going on, right, was this cubes thing. The computer just likes cube numbers. It wants to charge you based on cube numbers divided by 3. You ask it to add together 2 and 3, and it says, ooh, you need the number 2 and the number 3. I love these. And then I have to give you the number 5. No, that cube is much larger. 5 is my favourite because 5 cubed is huge. I will charge you £30. Just 100 take away 4, take away 2 cubed is 8. 125 take away 8, take away 27. divided by 3. Yeah. Factor of 3. Think and therefore I haven't. Right, interviews are tense, otherwise cool. But on the prime number one, I've got 10 minutes. Oh, I do need to go in a minute. Let's do the prime number one really quickly. Any other questions? But I feel like we're exhausting the questions very quickly at the end. Actually, this is a mini interview question in a way. I did this in a video with New College semi-recently. I guess this is something about me that I use everything multiple times. Sorry. So suppose P and Q are prime. Given PQ and P minus 1, Q minus 1, how could you find the values of P and Q? This is based on a throwaway comment I saw towards the end of some number theory notes. So, I mean, possibly someone's read lots of number theory notes, or maybe they've thought a lot about RSA, but they've thought quite a weird question about RSA, because in RSA cryptography, this is something that you publish, and this is something that you don't publish. So if you publish both, then presumably somebody can work out P and Q now, but the question here is how? What on earth would you do? Obvious answer is factorize both. Well, that's hard. If I could factorize numbers, I would only need PQ, right? And then I'd factorize it and I would know the primes. So I'm not going to let you factorize both. Can we do something else that doesn't involve factorizing? You count the factors or something, then, well, you know. Okay. Oh no, that is 5n over there, isn't it? I think that's what you're saying, maybe? This is the number of things that are coprimes. Anyway, whatever. Not relevant, but true, but not relevant. But it's a question. From the interview, will we have a good idea if we get in, say, if it goes well? Personal experience. No, you'll have no idea. I thought my interviews were terrible. I thought my interview singular was terrible. Halfway through my interview, I tried to simplify 5 to the power of 4 divided by 6 to the power of 4 by crossing out the 4s to give 5 over 6. This was corrected because this is wrong. In an exam, I would write that, I would never see it again, and I would lose a lot of sleep. In the interview, they stopped me, they corrected me, and then I couldn't do the question, so I did lose quite a lot of sleep. But then I got in, so, you know, I did something else, I suppose. We couldn't do that question, so we switched. Find the difference. The difference is interesting, right? So the difference between these is P minus Q plus 1. The difference... Oh, handwriting's gone. I've got to move the pen to the right as you do the different letters. Difference is P plus Q minus 1. Nice, I like it. Now what? So we now know, well, we know 3 things now. I suppose we know PQ, we still know P minus 1, Q minus 1. Now we know P plus Q minus 1. What else? Almost there. Have I dealt with it about how did I deal with rejection? That is slightly too personal, I think. I'm going to keep that one to myself. But the advice I would give you is that short term, everything sucks. Short term, things are terrible. Medium term, you find a different way. You find a different way to get towards the things that you want. And then long term, almost entirely unaffected by the short term. In context here, that might mean interview doesn't go well, sucks, feels terrible for a long time. Maybe that means you don't go to Oxford, maybe it means you do go to Oxford, or whatever. Medium term, presumably you're going to do maths at university somewhere. I think you'll have a good time because you've just watched 2 hours of maths content in a random assignment of things. I think you'll like the structured stuff a lot more. Long term, once you've got your maths degree, there's a lot of stuff you can do with that. Not necessarily maths, but like loads of things where eventually it's not even going to matter which university you went to. I know at the moment it feels like it really does, but I'd say long term it depends more on you than it does on your university. It's not the old days anymore, where you just turn up to a job and say, I went to Oxford, as I imagine it happening in the old days. I have more of an impression these days it's not like that. Right, Simultaneous equations gives a quadratic. Yes, go for it. What's Bliss say? P plus q by subbing in. Yeah, some quadratic stuff. We know p plus q, and we know p. We know p plus q, and we know pq. We can solve these. In particular, we can write down a quadratic. So let's call this d plus 1. This is the difference, and I'm going to add 1. So I'm going to call this d plus 1. And we can write down, let's call this a and b. We can then go and solve this quadratic equation, and we will get the roots p and q. And then follow up was to do this with more numbers, which is a bit of a silly way of changing it, because if you change the number of numbers, it's got nothing to do with RSA. Kind of doesn't really anyway. But yeah, good, right, good fun. Yes, so once you get p, you are at the top there developing the quadratic formula. I think once you have p plus q, you can square and then subtract 4 times pq. No, wait, what am I doing? What did you say? D minus 1? Was this p? I think this is a minus sign with a circle over it. Oh. Yeah, it's a minus sign with a circle over it. I'm really sorry. So this will be d plus whatever we're calling the constants. Point is, you know these coefficients in the quadratic, so we're done. I've done the algebra terribly there, in a hurry, very excited. If I were being interviewed, my interviewer would now say, "What's d? What's d plus 1? What are you doing?" And I would say, "Oh yeah, this difference is d, and maybe I mean d minus 1. No, I really do mean plus 1 to get the p plus q out here, the d plus 1. D plus 1, for sure." People are going to do this now, aren't they? Whatever. Right, good. I like doing these live. Occasionally we do like a pre-record where I interview a student or something, or a non-student, or like we do a sort of mock interview. Occasionally we've tried to do those at events. I like doing these online on the internet. There's a lot of you, and it's all in parallel. Right, so the p plus q, squaring that and subtracting 4pq gives you p minus q squared. Don't need a quadratic. Yeah, make your own quadratic. And then you subtract that, you get p minus q, and then you've got simultaneous equations to solve, which will involve adding together those things and dividing by 2. There's the 2 in the quadratic formula right downstairs. You write down the quadratic formula, right? In some sense. Checklist for the interview. We've actually got selection criteria. They're not very detailed, but we're looking for people who can. Let's see if I can memorize them. No, let's Google them. This is the interview prep. You've already had it. I don't really have anything else. This is all I got. Selection criteria for mathematical sciences admissions group. We're looking for stuff like, oh, this is really tiny writing, isn't it? This is a bit of we haven't updated this in actually ages, except I fixed a thing about whatever. Online interviews. We will look at, what does this say we will do? Aptitude, technical skills, capacity to absorb and use new ideas, ability to think and work independently, though we are going to help where needed, perseverance and enthusiasm. And we know that enthusiasm looks different in different people. But we've got obvious things that we're looking for, really. I like it when people can do the question without me doing the question for them. I can check for that by asking a kind of follow-up to see if they, once we've done it together, can they do it without me? A bit like on the course, really. Like in a tutorial, we do it together, and then I think, yeah, but can you now do it? So I can give the student one to do. I like it when people seem to understand what's going on a little bit as well, that we're not just doing the calculations. To here, we make a meal out of doing the quadratics together, then we might lose track of what we were trying to do, which is maybe a thing about quadratic equations, but maybe it's also a thing about just keeping track of what we're up to. Yeah. It's kind of based on RSA, the question, because PQ is a thing that you would calculate. You would keep your primes P and Q secret. You would release the product. I hope they can't factorize it. Hope there's no quantum computers, and or hope that the quantum computer is not very good at this. Good luck. You personally have to calculate P minus 1 times Q minus 1 to do RSA. You have to keep that secret, because if you release it, then people will use just quadratic equations to work out your primes. Not even any factorizing, not even any quadratic sieve or any quantum computers, just quadratic equation. So don't do that. Don't release that number. There you get. We got some RSA advice out of this in the end. Also, don't do RSA yourself. Don't code it up yourself. Just knowing what RSA is there are all sorts of mistakes you might make while trying to code up RSA that other people have thought of. Right, thanks. That was the MAT Livestream 2025. If you've got an interview, you are part of the way. I would say halfway there on a log scale. So you've done one thing, which was math submissions test, time for another thing. Halfway on a log scale. That's such a stupid thing to end on. Right, good. That was MAT Livestream. Thank you, Callie, for, 2 hours of whatever that was. Thank you, everyone, for joining in. If you've got an interview coming up, you'll find out relatively soon, and wish you all the best of luck with that. If you're watching along because you're applying next year, then guess I might see you next year in things like open days or online videos like this one. If you're subscribed to the channel, you'll get notifications about what we're up to. This is our second channel, Oxford Mathematics Plus. We have a main channel called Oxford Mathematics, without the plus, which does videos of our current faculty and students and staff and people talking about maths, and also has some recordings of actual lecture videos, including these days we're uploading entire courses of lecture videos that you can watch along, so you can see some content if you like. Some of it's extraordinarily difficult, but that hasn't stopped us putting it on the web. We have a project in January which is called Oxford Online Maths Club. When we started this, we thought it was for year 13 students, bridging them between, math is done for them, bridging them to university. It's also turned out to be quite popular with year 12 students and younger students. So if you know anyone who might be applying next year and they want to see some super curricular mathematics, so extra stuff that they might talk about in their personal statement, a little bit like the kind of maths YouTube space, but we're doing live videos like this one, you could let them know that this channel exists, and we're going to do Oxford Online Maths Club starting in January. There's a dedicated website for that one, a bit like we have the Mat Live website. If you put club on the end after the r/, or if you just search for Oxford Online Maths Club, there's no need to register or join or sign up. It's just another series of YouTube live streams with a slightly different colour scheme. That's going to come. In January. We'll run that, and maybe I'll see some of you there. Otherwise, as I said before, if it all goes well, I'll see you in Oxford. Otherwise, I think you're probably signed up to do maths somewhere. Maybe I'll see you for master's study, maybe not. I wish you all the best with all the maths that's going on. And as always, have a good evening, have a good weekend. Right, we did it, there we go. Yes, I think I now just switch it all off, don't I? Yeah, right. It's been fun, see you around, take care. Yes, gosh, I pressed this one. It has been a couple of weeks. No, we're going to hold this for a moment. Okay, bye.